Nice. Good morning, everyone. Thank you for joining. I think it's about time and we're on the clock. So let's start. I will give you the word to Scott and Keith, who are doing a presentation on do-it-yourself testing with Inferno Framework. If you wait.
All right. Thank you. All right. So hello, everyone. I'm Scott Bohon, and this is my colleague, Keith Carlson. So just a little bit about us. So IT specialist with the Office of the National Coordinator for Health Information Technology. I specifically work in the tools and testing branch, and I work closely with the API criteria in our certification program, as well as the privacy and security criteria. And then we have Keith as well.
Yeah, hello everyone. I'm Keith Carlson. Similar introduction for me. I work at ONC, and a lot of my work is I'm part of a team along with Scott of subject matter experts on our standardized FHIR API for patient and population services certification criterion, which we'll have an introductory slide on. So just an outline of this talk, want to spend as little time as possible on these slides because we're going to do some live demoing. But we're going to start out, I'm going to give a quick overview of the standardized API criterion in the ONC certification program. And then we're going to just to give a couple slide overview of what the Inferno framework is, kind of level set on that. Then we're going to do a live demo of executing existing tests, like tests that are available right now in the Inferno framework, how to get to the UI and how to execute those tests. And then we're going to do a live demo of writing some custom tests in Inferno. I'm going to walk through a couple simple examples in this tutorial. And then we have a Let's Build right after this, which I would encourage everyone to stick around for. Rob Scanlon, the project lead for the Inferno project, will be going through some more advanced testing and we'll have a lot more hands-on time. Then we're going to just end with a quick vision for the future. So we could have a whole session, multiple sessions on the G10 standardized API for patient population services. It's contained in ONC regulation at section 170315 G10. You might see a couple references to G10 throughout this presentation. That just refers to our standardized API for patient and population services criterion. But this was ONC finalized this criterion about a little over 2 years ago in the 21st Century Cures Act final rule. It has a bunch of different kind of standardized and non-standardized requirements in it. We have right now the app registration requirements are actually non-standardized. But the authentication and authorization requirements, we point to the smart app launch, the FHIR smart app launch framework, and say that health IT developers, EHR developers certifying to this criterion need to implement authentication and authorization according to the smart app launch framework. We also have data response requirements, and contained within there, we have, requirements for both a single patient and multiple patient API, right? The single patient API use case, an example would be a patient wanting to connect to an EHR and extract their data into a third-party app of their choice. That mostly just points to US Core as the data format for supporting that single patient API. But we also included a reference to the bulk data access implementation guide for a multiple patient API, for extracting, multiple data. And then we also have non-standardized requirements for, API documentation, or just we call out some ONC things that we want to see in API documentation to really support third-party app developers in connecting to EHRs that have G10, FHIR certified APIs. Okay, so now just with that quick overview of G10, we're just going to transition into talking about Inferno. So Inferno is a open source FHIR API testing framework that is focused on server testing and implementation guide testing. It was funded by, initially created and funded by ONC, and ONC created it as a test tool to test the ONC standardized API certification criterion. We make it available to developers. They can use it as they're developing their software. But then also Inferno is used by, we call them authorized testing laboratories for official certification to get the ONC stamp of approval when, certified health IT developers are ready to, certify. So, and it's developed and maintained by MITRE. So this is kind of a diagram of how, a high level diagram of how things are organized right now. I'm not going to dive into a ton of like everything specifically listed here, because I just think the main concept or the main thing I want to get across with this slide is just showing the modularity in the Inferno framework. That's really our goal, is to kind of have, we have over here, I guess on the right, like the Inferno core, which is like a set of like core services that are needed just to run tests in general. And like, it includes like the user interface, right? So you can like have a user interface to interact with your tests that you've defined. On this user interface, you see the results, can inspect any errors that you get. Those are like some of the core services. But the idea is we want to be able to plug kind of what we're calling, well, test kits, or there could be other packages and libraries, but want to be able to build this Inferno core in a way that you can plug other tests into it in a modular fashion, right? So we have like the G10 test kit. I just talked about how G10 kind of pulls in all of these different FHIR implementation guides. And so, all the way over there on the left, right, we just have the US core test kit. So like with how this is all built, we can create kind of a standalone US core test kit that someone just wanting to test with US core can like use that test kit. But then if we want to create like for our G10 certification test kit, since this is modular, right, G10 includes US core, we can pull in US core. We also have like a smart app launch test kit. You can pull in smart app launch into G10. So you can kind of use these test kits on their own, pull them together into a solution for a specific use case. You can create your own test kits and pull them together in different ways. It's really just about the modularity, and, all the work that MITRE has done so far is open source. So you can build off of that. We would love to see other people develop in this and make that open source, and just kind of, have these test kits available that can be combined in different ways and taken into the Inferno, used in Inferno core to run tests. And this is just a list of what the MITRE team is currently developed, what's currently supported in Inferno. A bunch of different FHIR implementation guides tested. We're about to go into a demo here, and you'll see how to get to these and how to run tests in one of these right now. So I'll pass it off to Scott to go into that.
All right, thank you, Keith. So before we get into the demo, I'm just going to go into an overview of how testing is structured in the G10 test kit, since it is quite a comprehensive API criterion. So in general, the philosophy is that Inferno is acting as a very demanding client, and it's going to perform reads for both a single patient API and a multi-patient API. And because both of these APIs are required as part of the G10 criterion. And so one thing that's interesting that Keith mentioned about how G10 is testing is that it's integrating multiple implementation guides together into one kind of testing package. So it starts out with authorization and authentication from the Smart App Launch framework, and then once that application gets that authorization and access, then it goes into testing conformance to US core. And so that's kind of something that's really interesting about the Inferno test kit for G10. It enables that kind of functionality. Also, another kind of useful thing in Inferno in general that is used in the G10 test kit is that a lot of the testing parameters can be reused, for subsequent tests, as well as materials that are collected throughout tests can be used in subsequent tests, just to make the lives of testing proctors easier as they're going through the testing scenario. They're automatically collecting things like access tokens that can be used as part of that integrated end-to-end testing of going from Smart App Launch to US core testing. Another component to testing in G10 is the use of test data. So when the reads are performed on the FHIR server, there has to be data to be pulled out, and for certification and testing through the G10 test kit, servers can either use data that's been generated using the Inferno test tool, or they can provide their own data, and that can be used as part of testing. And then lastly, all of these tests that I'd mentioned before, like for the Smart App Launch and US core tests, are generally automated. And for the tests that couldn't be automated, there are fields that can be used to capture information like attestation and other information that like from visual inspection of the module so that, that those kind of results can be recorded directly in the testing tool. And then just as a high level overview, there's a lot that's going into this test kit, 5 high level scenarios, 40, component sequences, 300 more individual tests, and, thousands of HTTP requests that go into this, G10 test kit testing. So now that I've gone over into an overview, I'm going to go do a walkthrough of, what it kind of looks like if we go to ONC's hosted instance of Inferno at healthit.gov and bring that up. So this is inferno.healthit.gov, which is a hosted instance, that ONC provides to use the Inferno framework for both testing to G10 as well as other test kits that are made available. So if we go down here, we can see that what is available for testing. We have a button right here to take us directly into the G10 test kit, or we can go through this additional menu to see that not only can we test with G10, but there are also other test suites that are available that we could test with if we were so interested in doing so. But for this demo, we're going to be using the G10 test kit or test suite. So we will test with that, but we could obviously test with just US Core, 3.11, 4.0, TLS tests. So they're all available on this hosted instance. So once we go into the G10 test kit, this is the menu that pops up. We start out with a general overview of what G10 testing is and how it works. And so before we would get started, there would be application registration to make sure that Inferno could properly access the FHIR server through the OAuth workflow. And that starts with application registration, which happens out of band. But then once that happens, then we can go into testing in the G10 test kit. And just as this overview page mentions, it shows all the different testing sections that have to be completed as part of G10 certification. So another thing to note is that Inferno has a reference server that provides demonstration functionality for what a G10 compliant server would look like. And so we would, Inferno has the option to select a preset set of testing inputs, and these are configured specifically for the Inferno reference server. So we are going to populate the testing parameters as per the Inferno reference server. So we'll get started with the standalone patient Smart App Launch Framework scenario. And what this is doing is testing that a standalone application can launch using the Smart App Launch Framework and get all the appropriate access information to be able to access the FHIR server. And so just starting at the top, we see this button to run tests. So we can, after reading the background information about what this test is doing, we can hit the run test button. And then this pops up the user input where the tester can go through and read about what's about to happen and what needed to happen before. So register that standalone application. And then once that registration step had been completed, then we get all the information that is needed to complete this standalone test. And so as I had selected the Inferno reference server pre-selected configuration, it's populated for me all of the information that is needed to do this standalone launch test. So we have things like the Inferno reference server, FHIR endpoint. We've got the credentials that were obtained through the application registration process. The scopes that are being requested as part of this test, and then the optional. Pixie is an additional security layer on top of the Smart App Launch Framework. It's not included as a requirement in version 1, but it's included as an optional feature for developers that are interested in certifying using Pixie as part of the Smart App Launch Framework. And so we could enable it. And so we'll do so for just this demo. And so all this was done using the kind of easy to input fields. But if we were so interested we could use a paste-in field for in either JSON or YAML format. So just if we wanted to go through this quickly, we already knew exactly what we wanted. We could just paste in a JSON or YAML configuration and go through that process that way. So now we're going to start the tests, and we're going to go and go through the Smart App Launch Framework. And so this is the authorization screen. So the standalone launch app process has started. We're going to select that we're going to authorize the requested scopes for this application, and we're going to click authorize for all the listed scopes. And then, once the testing has been completed, we can go see the test results. So Inferno lays out through these menus, all the information that was gathered during the testing for, this test section. So initially, there was testing for the configuration just to make sure that all the, the prerequisite information is available, like, the endpoint information and all those kind of configurations are available. And that's what these tests are completing. And then we get into sort of the launch, information. And so if we were interested in seeing, what these tests were doing at the HTTP level, we can, further expand down into each test and kind of see what, information is available about each test specifically. So, we have information here like, TLS was used. And then if we have specific HTTP requests we're interested, there's none for this one, but, for example, this one, we can go into actually what the HTTP requests, HTTP requests were for, say, like this specific example, where the OAuth server is sending the code parameter. We can see what the that request looked like and all the HTTP information that was part of that request. So if you're so interested in seeing the exact technical details of what into a test, that is available for viewing. So now that we've completed this, Smart App Launch test, we can go into the next section, which is the sort of the same kind of workflow, except now it's limited access. So instead of going through and authorizing all those scopes that we were interested in before, we'll instead say we just are interested in the patient resource, and instead we'll only authorize the patient resource for this test. So it would essentially fail if it allowed anything more than that patient resource access. So again, and then you can see that Inferno is doing work for us. It's taking the input parameters that were used in that previous test, and since they would be the same for this test, it's automatically populated and locked that information as part of the test inputs. So it's essentially saving us time by just taking what would be reused and just automatically reusing that. So again, we're going to run this test and then go through that same kind of OAuth workflow, except this time we're going to just disable everything except for the that patient resource, and that's how we're going to see that indeed if we don't enable or if we only enable that patient resource, that's all we get in terms of FHIR access. So we can see here that once we only authorize the patient read and that patient context scope, we pass these Inferno tests. So then the same thing would happen for the EHR launch. This is the Smart App Launch EHR launch scenario where the application would be launched from within the EHR. So very similar. So I'm not going to go through this test, but essentially it would be very similar to the previous test, but just launching from within the EHR. And so now that we've kind of gone through these Smart App Launch tests, then we can get into the US Core and US CDI tests. So these tests would be testing for the FHIR server is providing resources and storing resources that are using the US Core profiles and conformant to those profiles, and can also support those mandatory must support elements that are defined in US Core, and also can support the required searches as stated in US Core. So if we were going to run these tests, we also get additional input parameters like what patients we're looking at, and then again, it's doing work for us. We automatically know, using those previous launch tests, what the access token is to get access to the server, and then the refresh token that's involved to refresh that access, and it's populating all this for us so that we can quickly just run into the next test. And so it's going to run these tests. For the sake of time, I'm just going to move on to the next section, and we can do that. It'll run in the background as we're we look at the next section. So all that was for a single patient API. So for accessing the data of a single patient. The G10 criterion also has a bulk data API requirement so that population level data can be accessed. And this requirement for G10 is specifically that the group export functionality from the bulk data access implementation guide is available and can be used, and is secured properly using the backend services authorization guide, to complement the bulk data access. So if we're going to run these tests, again, we get a similar kind of a pop-up menu where it was required to perform registration, and then going through again, these are just additional parameters that are specific to the bulk data section tests, and we could run through these and run that, but for the sake of time, I won't specifically just run through this, so I can get to the additional tests section. So there are sort of a collection of miscellaneous tests that didn't really fit into those categories above. And so this is where things like token revocation would occur. So as part of the Smart App Launch framework, we got an access token and a refresh token that are used to access the FHIR server. And to demonstrate that a server can revoke access that was granted, we could run through this kind of test to revoke, so that once the server had demonstrated that it can revoke a token, then we would run this test, and it would essentially test that access is denied once that access token has been revoked. And then just going through, for example, like the public client launch test is where all those previous tests were using confidential clients as defined in the Smart App Launch framework, but it's also required to support public clients. And so this would just be running through that Smart App Launch scenario with a public client. And then just ending off with visual inspection. So then, anything that wasn't, automatically done can be captured here using the, visual inspection, just to make sure that the module is doing, what it's supposed to be doing for G10 requirements. And then once we've run through all of the tests, then we can look at the test report just to see, what exactly, the results were for, the certification. So that will conclude the G10 test kit demo. I'll hand it back over to Keith to run through the rest of the presentation.
Yeah, thanks, Scott. So just going back here, because now I'm basically going to go into, we're going to write some simple custom tests in Inferno. And I'll share my screen and show how to do that. But just to first, really, I kind of want to go through this quick just to get into the demo, but, just to talk about the Inferno test design approach. The Inferno Framework design defines a Ruby domain-specific language that can be used for writing this test. We'll see all the documentation for that and how you can interact with it. I talked about kind of the modularity of being able to organize tests in different ways. And there are other patterns provided within the Inferno Framework to do things like generate tests based on structured data, right? Like take a capability statement and generate tests that can be run in Inferno. And then there are also patterns to test your own tests, right? Like we have the full power of Ruby, for writing tests. You can use any other components of Ruby. And so you might want to be able to test Ruby logic or something like that. And there are patterns to do that. So I'm going to hop right back over because we're going to go to the same, let me make sure I stay close to the mic here. Go back to inferno.healthit.gov, the same place Scott was just at. But the place I want to specifically call out is this card here on the right, talking about the Inferno Development Framework. This has the information and links to where you need to go to learn more and get started on writing tests in the Inferno framework. So I'm going to just click on this big Learn More button down here. And this will bring us into the kind of this landing documentation page, which there's a lot here you can kind of click through yourself. I want to make sure this isn't forgotten. These two links up here, I just want to call these out specifically, that like at the top, you also have a link to these like Ruby API docs, which, you know, has a class list, you know, defines all the classes and methods for the Ruby domain specific language. And then we just also have JSON Swagger API documentation up here if you want to, you know, use the APIs to kind of interact with the Inferno backend. So basically we're at this landing page here. We can go to Get Started Now. And within the table of contents up here, we have a specific section for getting started for Inferno test writers. And this is it. This installation and running Inferno are the two main things you need to get started. Using Docker, it's pretty easy to get started and get running, because all you need to do first is install Docker, and then we provide this Inferno template repository, which I'm going to go back to. Not sure why it's loading, but why it's not loading. But I'm going to go back to this template repository in GitHub and be basically working off of a fork of this to run these tests. So let's hope. I don't know why GitHub's not loading right there. Live demos. But we have that template repository, and then once you like clone that template repository, there's a setup.sh script within that template repository that you can just run to automatically retrieve Docker images and create a database. And once you've done that setup, you can run and stop Inferno kind of ad hoc as needed, right? You just do that setup runs, and then as you're writing your tests, you can run Inferno, which sets up a local host for you to navigate to run test suites. So let's go. So I want to go over to here. I have everything set up to run locally as a backup if we need to, but connected to the internet. This is, yeah, okay, yeah, is it still streaming on Zoom? Okay, so the internet's still working. Okay. Whew. So this is hard. Live demos. So we have this is a, you know, you can look at this link. This is github.com/inferno-training/inferno-tutorial. We're going to be going into this in the Let's Build. This is a fork of the Inferno template repository, like I mentioned. And I'm going to be doing this demo out of a GitHub code space, which I'm just going to open in a new tab. I'll go back to that. Please be sure to come to the Let's Build. We have a whole setup where you can send us your GitHub usernames, and we'll allow you to kind of set up your own GitHub code space within this repository to follow along with us without having to install Docker. And we've kind of have a budget to like support this for the next session to, you know, cover the cost there for people who want to just get up and running. But within this repository, we have a wiki here where we kind of define the steps over here on the right that we're going to go through. I'm going to see if I can get through these first 3 steps in this session right here, but we'll have more time to go over the rest of them in the Let's Build. So I'm just going to open this, but go back here to the GitHub code space that I started up. So, you know, this gives us a neat little in-browser Visual Studio Code editor. You know, we've got a command terminal up here that we can run different commands in. I want to really drive home the point that there's not like a ton of setup I've done here in like the background to get this to work. This is all going to look similar if you do this locally. If we just go back to the instructions, right? You need to install Docker as a step 1. GitHub Codespaces already has Docker available. When you launch a GitHub Codespace, Docker is already there. And so that was really easy. The next step is like cloning the Inferno template repository. This is built off of the Inferno template repository. All of these files here on the left, you know, are stuff that's already included in that template, right? This isn't stuff I've like defined now. You know, you can easily get started with all this. So I just don't want all of that to like look overwhelming or anything. And then last night, I just already ran the this setup.sh to do the setup. So I'm like not going to do this setup live right now, but you know, if you're setting this up for yourself for the first time, oh, I stopped the share. Let me bring that back. If you're running the setup for the first time, you know, you would run that setup. So let me go back here and just go ahead and do run.sh. Let's see. I don't know if it'll do that. And does that work better? Okay. Thank you. So I just did that run.sh, and GitHub Codespaces kind of does this fancy stuff to like basically give us kind of a unique URL to navigate to. Once we do run.sh, we want to look for this listening in the console. You'd see this locally too. This is kind of a GitHub Codespaces thing. It like forwards it to this specific address, which don't worry about this. I'm just going to make this public. This makes it a little easier to, I find it's a little bit more stable, but I just basically copy this address. And when we go into here and paste that, if you're local, you would just type in localhost. You now see the UI for the Inferno test suite template. And this is what's included in the template. We have like a simple read capability statement test, and then a test to read a patient and validate the patient resource. Let's go ahead. Yeah, we can run this super quick, because if we just run it, and I already have I can just put in the Inferno reference server. This is the MITRE team, hosts a Inferno reference server that we can use for testing. I know there's a patient with ID 85 on this reference server, so I'm just going to point Inferno to there. It's going to run. The patient tests are going to fail. So it was able to read a capability statement, but the patient test failed. If we look at the HTTP request, we can see that we needed a bearer token. This is, we need a bearer token to access the server, and that is not provided. And the Inferno template does not automatically include a hard-coded bearer token. So I'm just going to exit out of that and then stop the Inferno run. Every time we make changes to tests, we have to rerun the run.sh script. But if we go back to the wiki, step one for what I'm going to walk through here is accepting user bearer token input, just to show how to do that really quick, right? The UI, this is just a screenshot of what we're given. We have an input for URL and patient ID, but we want to add a bearer token input. And so to do that, within the Inferno template repository, we can find this code in the lib directory, this Inferno _template Ruby file. And then basically, this is where we input our URL. We just want to add another input for I believe we just do input access _token. So we add that there, just defining a new input. And then in the FHIR client, we can set the bearer token variable to be equal to this access token that we defined up here. Adding these two lines will now automatically add a field to the UI where we can type in a bearer token. So I have that there, and I'm just going to move on. That we'll see this in the UI when I run this for a final time. But instead of running that and showing that specifically, I'm going to go to step 2, and we'll see this all together. Because we have this step 2 scenario right here. We're going to go ahead and create a new search test, which it is not loading again. Have a local file too we can use if needed. Yeah, it looks like I'm having GitHub issues on this network. And the stream is still working, Ardon? Yeah. So it's like my computer is, well, if this keeps happening, I'll just switch over to my local. I want to show you guys how to, paste it in there and everything. But let me start bringing that up just so I have it. So I have just a source folder on my PC here where I can go into Inferno tutorial. Let me open this up in Visual Studio Code. Why do I not have the open with code down here? Sorry, just navigating around. Don't worry about this. Okay. So yeah, I'm just going to give up on using GitHub, I guess. Okay, I'm sorry about that because I added. So basically, what I've already done is, and can I zoom in here on this? Okay. So in that last step, I showed how to add this input access token and also add a bearer token. But what I was going to do was, again, remember we're in lib, we're in this Inferno template Ruby file. We already have down here at the bottom, we have this we're importing the patient group. These are where the patient tests come from. On that UI, we saw that we had a simple patient read and validate. Those are defined kind of in a separate file, this patient group right here. And we pull those tests in with this line. But basically, I added this new kind of condition search test. And And so, just to show off where this came from, like, let's say, for example, I'm going to navigate over here to the US Core version 3.1.1 implementation guide. So just to kind of tie this into a story for a second, let's say you were trying to implement the US Core 3.1.1 implementation guide and you want to test your implementation. We already have a patient read and validate test, but let's say we are looking at the condition profile. I'm just going to go to the US Core condition profile. We're scrolling through this and we see down here that there's a mandatory search parameter for condition search on patient, right? You need to be able to search for conditions referencing a specific patient. This is a shall support. So we can easily write a test for this in Inferno to test that your server supports this search correctly. And that's what the code is that I've added down here. I actually want to just go ahead. I think in a nice way, I can minimize these and just show the individual parts. Basically, you define a group block first. Then within the group, you can give it like an ID here. This is search underscore test is an ID I've just given it. I've titled this group search tests. This input right here just passes in the same patient ID that we used for the patient group, right? Like if you remember on the UI, it asked me for a patient ID. That is passed in through this line right here into this group. And then we have to create a test block, right? We have this test block right here. I just, again, created a title for condition search by patient. And then we have, this is the block of code for kind of adding in that search. So let me see if I can go back, even if GitHub doesn't load, I can just quickly find the, okay, so it's back. So I'm following like, in the GitHub wiki, step 2, I'll just go look at this, within the Inferno documentation, right? Like I showed, if we're on inferno.healthit.gov, we can click learn more, go to the Ruby API docs. And within here, we basically have the, within these docs, we have the definition of the FHIR search method. You can find this in FHIR client section of the DSL. And so I'm just using this FHIR search method that they've defined. You pass in a resource type, pass in some parameters, and it will execute this FHIR search, right? So that's this line right here. I want to search for a condition, and the parameters I'm passing in is I want patient to be equal to patient ID. And then I'm just going to, all I need to write to assert some things on these search, these search results are these 3 lines right here, right? So I added in a assert response status that like the response was HTTP code 200. I want to assert that the resource type is a bundle. And then this assert valid bundle entries method, will validate each of the FHIR resources in that bundle. And I specifically passed in like a reference to the patient condition US Core profile, which again, I just want to mention that I had this all stepped out better if GitHub would have been working earlier. But when you pass in this, you can just do assert valid bundle entries like this. You can just write a line of code like this and it'll validate just against base FHIR. But by passing in this US Core condition profile, it kind of tells the validator to use that. And all you have to do in that situation to support that, if I go back to US Core, the US Core IG, if you go to downloads, they provide the package right here, which you can download the package. And then back here, you can just drop that into the lib/inferno template/IGs folder. I've already put the package right here. So that's there and it'll work and, be able to find this structure definition for US Core condition to validate. And so I already have this all running, this like local thing, just in case something messes up again, I'm going to go to my local run here. I've already executed the tests. So remember in the template, all we had were capability statement and patient tests. But now I just want to show off when we click run all tests, we get our access token, input right here. This is where we can put in the sample token. That was the code I added before for this input. And, when we click submit, it'll kind of run through everything. We see that the capability statement was read. The patient was successfully read now because we've passed in a token, an access token that it can use to make the request. And it was able to validate it. And then we have our search tests in here, right? From that line of, from that FHIR search, we're now able to do this condition search by patient. It was able to run this HTTP request right here, a GET to the reference server for condition referencing patient 85, and validate that against the US Core condition profile. So yeah, I'm just going to go. Yeah, that was our kind of crash course. Again, I encourage people to stick around for the Let's Build, and you can go back and look through all the steps I did in that GitHub wiki that I showed before, which is, in the linked right here, this Inferno training / Inferno tutorial, which we're going to use for the Let's Build. So if you stick around for Let's Build, you'll be able to get to that and see that wiki. But to close things off here and be sure to leave time for questions. Yeah, Scott, you want to cover this really quick?
Sure. Thanks again, Keith. So yeah, again, we showed that ONC hosts the that instance of Inferno up and is available with all those resources for learning about both the G10 certification test kit, as well as custom made Inferno test kits, and all those resources are available to help design those. And as far as where we see Inferno Framework going, we want to provide support, to build a community that both supports the Inferno core, so a lot of those core features that are used in conformance testing, and it's also a community for designing test kits in general, for developer use cases, such as supporting implementation guides and things of that nature. And then just showing that there's from the level of a large conformance testing project like the G10 certification test kit, but then just down to very simple tests that you can write yourself, and we try to make it really easy to writing tests easily accessible. So I think as far as if you want to learn more after DevDays, you can reach out at our emails and or through the Whova app. And there's a lot of resources included in this slide about where you can get Inferno resources, documentation for at the technical level, and as well as just all the latest news at the Zulip thread on chat.phir.org and the Google groups. I know a lot of sources of information for where you can learn more about the latest Inferno news. So that concludes our formal presentation, and I think we're open for questions.
Nice. Thank you very much. We still have 3 or 4 minutes for questions. Are there any? Yeah, nice. Coming towards.
Thank you. Good job. Anyone who's doing testing considered good in our book. I'm Mario with Aegis. One of the points that I would like to make is one of the reasons I'm here this week at DevDays and talking is about some of the context around testing. We could use more help from ONC and others as we try to help the IG authors recognize, and I'm sure you're going to align with this, it's really hard to get an IG thrown over the wall and thrown to a bunch of us who are trying to develop tests saying, here's the IG, go build some tests. We want to do FHIR-based testing more than just schematron, more than just the messages getting across the wire, HTTP, okay. But what we're missing, there is a context here that we're missing. We're not seeing the community develop enough test cases. And we believe that during the IG authoring process, that there's a really good opportunity for the IG authors and the IG authoring process. And this is one of the talks I'm going to be having with the FMG, and I'm hoping that ONC will join, where we talk about, hey, when you publish an IG, please publish the test cases so that we can do the test tooling. We can agree to disagree on which test tooling we should do and whether it's Ruby or test script or whatever. We can agree to disagree on that. But we should all have, when you put together the package, and that's one of the things I was hoping you would get to, is the test methods and the test cases that feed into how you build your tests in Inferno. That is really critical stuff. And there's not a lot of review going on test cases. And we think that when you ballot an IG, if you ballot the test cases, then you're really going to look at how the IG is going to work. And without those test cases being defined, it means your work is harder and our work is harder. And ultimately, the FHIR community loses great opportunity and fidelity around what these IGs are trying to do.
Absolutely. Yeah, thank you. Do you want me to try and, because I know like there's a ton of like the goal with Inferno Framework, you know, is to open this up. And we would love to see like the community create test kits and share them. But I know that like Inferno specifically uses Ruby, right? And there's also the test script FHIR resource. Working on a common API. Yeah. For both of those. Yeah.
Separate the tooling.
Exactly. Yeah.
We're confusing some of the conversation. Like I want to take the tooling and not even mention it.
Mm-hmm.
Just talk about the test cases, because right now, the only thing we have to work on is an IG and an imagination that we know what the IG authors were thinking. We need those test cases, and your input along with ours and CMS and others can help the IG authors know that it's not good enough just to throw an IG over the wall. So that, you know, that,
No, thank you.
If you
Yeah,
can help, that would be greatly appreciated.
Noted.
Nice. Okay, I think we're at time. So thank you very much for your presentation. It was very clear. And well, let's give them an applause, right?